All right, in this unit, you're going to hear the term identity being used quite often, so you need to know what that is. And so an identity is just a statement of equality where you can use anything. It's true for all values of the variables. So, for easiest example ever, x equals x is an identity. You put something in for x, equals x, equals itself. All right, but there are lots of things in trigonometry that are identities where we can write some sort of equation and each side is always going to be equal, always, right? That's what an identity is. So a trigonometric identity is just one using trig functions. That's all the differences. So learning target 1 is just using the unit circle to give a counterexample. So they're going to give you some expression or some equation, and you're going to have to show that it's not an identity. So if you find one value on the unit circle that makes it untrue, it's a counterexample, right? So there are ones that have multiple answers, and that's fine. So just the answer I give is not actually the answer you have to have, okay? So here are two examples of that. You have some equation. If they really were equal for every single value of theta, then it would be an identity. But in this case, they aren't. So we're just looking at the unit circle to find some value for theta, so some radian measure that disproves both of these. Okay? So the first one's relatively simple because it says sine plus cosine equals tangent. So we're going to look at the unit circle. You're going to pick some radian measure. This would not be true. Now, you have to find tangent for one of these, so you know tangent is y divided by x. You might want to choose one that would be easy to find tangent on. So if you look at pi over 2, perfect example. There's multiple answers on here. Remember that you have sine and cosine, right? What would be the tangent at pi over 2? Undefined. So if I was going to put this into my example, sine of pi over 2, if we're using theta equals pi over 2, you don't have to. Sine of pi over 2 is 1. Cosine of pi over 2 is 0. And that's supposed to equal undefined. Does 1 equal undefined? No. So that's a perfect counterexample. Again, there are others. There are plenty. It's not the only right answer. Or you're just showing that they're not equal to each other. All right, so the second one is saying secant squared x plus cosecant squared x equals 1. So remember, secant is just the reciprocal of cosine, and cosecant is just the reciprocal of sine. So again, we can choose different. Now, some of them may work out, but it's telling you to find a counterexample, so I know that you can find at least one. So again, look at the unit circle, and you want to pick some value, some way, somehow. I would not suggest using pi over 2. Pi, 2 pi, because if you take the reciprocals of some of those, you end up actually getting 1. So tricky. So let's just pick. I don't know. Pick one. I don't care. Pick. Pi over 4. All right. So if we're looking at pi over 4, that'll be easy. Secant squared, well, secant's reciprocal of cosine, which is square root of 2 over 2. So we have 2 over the square root of 2 squared. Same thing for cosecant, it's the same value. So in this case, we square the top and the bottom, right? So 2 squared is 4. And the square root of 2 squared is 2, which is just 2, and that happens both times. And what's 2 plus 2? It's definitely not 1. So pi over 4 would be a perfect counterexample for that. Okay? Yeah? Right. If you happen to choose something where it actually equals 1, that's not going to be a counterexample. So then you go back and choose something different. All right? Does that make sense, though? Okay. That's learning target 1. Yes. No. You don't have to show your work. I show it to make sure that everyone follows, but you don't have to if you know for sure it's going to work out. Yeah, so the answer is just the radian. Just finding a counterexample. All right, that's learning target 1.